This is the video for the data mining course, and I would like to continue the section about data preprocessing. Last time we finished until this part, we're discussing about the sampling, and we learn about the sampling which is related to cluster or stratified sampling. And I will explain about the data cube aggregation. This aggregated data for an individual entity of interest can be seen in this diagram. If you look at this one, you can see that it is a kind of cube and there are three kind of attributes. The first is about item, and this is about time, and this is about the location or cities. And if you look at this, um, this is a data about sales, and we can see the sales with regard to the time, location, and the item. For example, I want to know about the home entertainment, and this is the sales in the quarter one, and this is the sales located in the particular city, for example, Vancouver. So using this kind of data cube, we can see many kind of attributes in details, or we call it multiple levels of aggregation in the data cubes. We can further reduce the size of the data to deal with, let's say we have the data in the quarter one and we want to expand data into particular months such as January, February, and March. Or if we think that the months are too detailed, we can build up into the quarter so the data size can be reduced. It is a reference to appropriate levels, and it is expected that you have data in the smallest representation, which is enough to solve the task. Now, let's go to the orange. So we can learn how to select rows, and we can learn how to select the data. Uh, Now I'm going to open my orange, and with the file, okay, with the file, you can just go to the iris. If you still remember, we have the iris data set, and this iris data set contains of four attributes. We have the sepal length, sepal width, petal length, and petal width. And there is one attribute, we call it as a target, and this data contain of the iris name, iris flower name. Now, I would like to select some rows, and you can select the widget select rows. If you make the widget, give it a moment, please. I think we need some time to open the widget after you open the widget file. Yeah, in this particular data preprocessing, there are some widgets that you can use. For example, the select column, select rows, and there's another kind of widget that might be useful for you. For example, we can use the linear regression, and we can use the data sampler. Yes, so we can select the rows, and let's say I want to select only the iris equal to setosa. Okay, if you select the iris, and in the middle of this column, you can see there are some options. For example, is, not, is one of, or is divine. So let's say I'm going to select only the iris setosa, then yeah, you can go to the data table and you can see that only iris setosa is selected. It means you can reduce the amount of data, so you can just use the iris setosa for further analysis. Now let's look at the other widget. We are going to select the columns. Let's see, I'm going to select only two particular columns. Okay, now I'm going to use the column petal width as the features, and I'm going to use the petaling as the target. Meanwhile, I put the other attributes as ignore. It means I will not use iris, I will not use sepal width, I will not use sepaling. So this is the independent variable, and this will be the dependent variable. Now, if you look at this widget, you can continue to another kind of widget. For example, I will use the linear regression. Okay, let's look at this one. Yeah, I can use linear regression, and you can look at the coefficient. So we already learned a little bit about the linear regression. So this is the coefficient, or we call it the intercept, and then this is the petal width, or this is the coefficient of the petal width. In this case, we can have an equation. For example, this is the attribute petal width. I have the intercept is 1.09 plus the petal width. You have the coefficient 2.22, which will be multiplied with any data in the petal width. So if you input any data in the petal width, you can multiply with 2.22 plus the intercept 1.09, and you will have a predicted result with this kind of linear regression. Now, using this linear regression, you can build kind of scatter plot. Now, I'm going to use the scatter plot to make it more visualized for us. And you can see here the data with this line. We have the correlation. We call this R is correlation, and the R is 0.96. So we can say that this data is very highly correlated. Because this data is highly correlated, then I can just select the data that might be useful for my further analysis. For example, the data which is far from the line, I will not include for my analysis. So you can use drag like this one. Okay, so you can drag, and then let's say I'm going to include this one. So you can press the control. You can press control, and then you can select with drag of your mouse, and some of the colors you can see it becomes orange. So this orange data, it is the selected data, and once you move to the data table, you can see this is a selected data, and you will see that only 133 data. So it means the data that you selected will appear in this data table. So all the data will be in the G1 or it is in the group 1. Yeah, this is one way to reduce the amount of data. And because we have this line, we want to select only the data that is nearby the line. We can also use distribution. Okay? So if we use the distribution, you can take a look only some data that might be useful. For example, I have this distribution and then I want to, yeah, you can split by the iris and then I can make the distribution of sepal length, sepal width, petal length, and petal width, and you can increase the pin width. Okay, you can increase the pin width and you can decrease the pin width. And well, for example, I would like to select the petal length, which is less than 5. Okay. So I can select the petal length and then I would like to this is not stack column, so I can just reduce this one into here, and you can increase the width. Yeah, if you increase the pin width until 5, then you can see that if you click on this part, then this is the data that is less than 5. And if you click this one, then this is the data that is higher than 5. Let's say I'm going to choose the petal length, which is less than 5. After you click with this rectangular, then you can continue with the data table. So you can see now we have 104 instances. Okay. And this 104 instances is related with the data that petal length less than 5. So you can just look at the column petal length, okay, and all the numbers will be less than 5. So this is a kind of conditional, or you can filter the data based on the particular condition of the attributes. The last one that I want to teach from the orange, you can look at the sampling. Okay. So I'm going to continue this link or this widget with the sampler or data sampler. And in the data sampler, you can see there are some sampling type. So the first sampling type is fixed proportion of data. In this case, you can select, for example, 50%. Then I would like to get only 50% of the data. You can click sample data, then you can see there are 75%, 75 data will be selected. And if you continue with the data table, then you can look at the number of instances. Now it becomes 75. And if you increase the proportion rate, yeah, of course, it will give you the data based on this percentage. The other type is fixed sample size. So you can look at this one. There are numbers on the instances, and you can select the sample with replacement or without replacement. So you already learned what is a sample with replacement and sample without replacement. You can do also the cross validation, but I will keep this one for later. And bootstrap, I think I will not explain more because of the time limitation. And what you need to look at more is this sample. You can see there are options. It is a replicable or deterministic sampling and stratified sample when it is possible. Now, I would like to show you if we are dealing with the stratified sample. Let's say I'm going to select the data, okay, sample without replacement. Let's say I'm going to have this 75, okay, or this is the 50% of the data. I'm going to open the distribution to show clearly about the percentage of the data. If you look at this data, the iris setosa is 38%, and the iris virginica is 30%, and the iris versicolor is 30%. What does it mean? The distribution is not the same. Okay? The distribution of this data and this data and this data, they are not the same. If you change the data sampling method using the stratified sample, it means the tool will try to make it balance. So you can see that the iris virginica, iris versicolor, and iris setosa, now they are in the similar percentage. You can look, you can move your mouse, and then you can see the data here. Now it becomes 33.33%. And this is also 33.33, and this also 33.33. It means when you click the option certify sample when possible, the orange tool will automatically look for the possible categorical data to find it as a stratified sample. So you already learned the stratified sample. Yeah, you can use also this stratified sample in your data set. Next is about the data reduction. The data reduction, um, we already learned two prior concepts. First is about the dimensionality reduction, and the other is about numericity reduction. And the third is about data compression. So the data compression, it can be about the string compression. String. What is string? String is text data. So everything related to the text, we call it string. And there are extensive theories and well-tuned algorithm. And typically it is lossless, but only limited manipulation is possible without expansion. We will look at the details what is lossless. There is another kind of data compression for other data type, that is audio or video. The audio or video typically lossy compression, and we call it, this is with progressive refinement. There is another kind of data compression with regard to time, or we call it, this is the time sequence. It is typically short and very slowly with time. The dimensionality and numericity reduction may also be considered as forms of data compression. Now, if you look at this concept, you will see that the raw data will be something like this one. We have like 6 columns, and we have 8 rows. And when you compress the data, you can compress with regard to the rows, and then you can compress with regard to the column. Now, what I want to mention to you is about the lossless and the lossy compression. The lossless compression means we have the original data, and once we compress the data, we can written back to the original data without any loss. So that's why we call it as loss. So the loss it means no loss when we return the compressed data into the original data. Meanwhile, the original data that has been compressed, there is a possibility to have some loss. And if it is lossy data, then the original data will be approximated. Approximated means, yeah, not really in the form of original data. So this is only a kind of approximation. Maybe it is not clear, it is not that obvious, it is not the same with the original data. So we call it, that is the lossy compression. Okay, so let's do the learning check. How many data reduction strategies do we learn? Yeah, I think by now you already learned at least three kind of data reduction. So you will learn about the dimensionality reduction, and then you learn about the numericity reduction, and then you learn about the data compression. Okay. So how many dimensionality reduction techniques do we learn? In the dimensionality reduction techniques, okay, there are some methods that we learn. The first is the wavelet transformation, okay? And then we try to use the principal component analysis, okay? And then we try to apply the feature selection, okay, with the feature subset selection, okay? And we can also use the feature creation. Okay. What about the numericity reduction? So how many numericity reduction techniques do we learn? Yeah, there are various kind of numericity reduction. Yeah, we can use the linear regression, and then we can use the sampling method. We can use the histogram. So we can select the data based on the distribution, and we can also select the rows manually, or we can also use the clustering and other things. Okay. Can you mention any type of data compression? So there are two type of data compression. Okay. We have the loss, and we have the lossy data compression. Okay. I will stop this video. I will continue the next section with other video. Thank you.